Over the past 6 months, I've been building a stack of parts to build a modern wooden runabout. The boat is called Temptress. It was designed by Michel Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. That stack of parts you can see is next to me here, and I've just brought them down from the upstairs workshop to begin to start laying the boat out and standing the frames up and turn this pile of parts into something that actually resembles a boat. So let's take a look through all the work that I've done to date to get me up to this stage, and I'll bring you up to speed on the project if you're new to the channel. So let's get cracking from the beginning. Okay, so to start out building the frames, we need a frame construction table. And this is what the frames for this boat get built on. So this consists of a CNC cut melamine sheet, and I decided to frame this in some timber and actually turn this into a table. I'd originally designed this board to just sit on the floor, but from watching other people build some of these boats, I realized that this was a really good opportunity to turn this into a multi-function table as well. So you'll notice that I've also got the addition of a load of MFT holes cut within the top surface, and that turned out to be a really useful thing actually for using this for clamping the frames down whilst we built them. So you can see this is 2 sheets of melamine that are cut and joined together with a dovetail system up the center. When it comes to building frames, all of these frame parts have 2 holes that go through each component, and they correspond to holes that are drilled in the frame construction table. You can see that they're marked with the numbers there. So a little plastic dowel goes through the frame part into the frame construction table, and it locates that frame component and allows me to get it true and square within reference to everything else within the boat. This will also allow me to transpose things like water lines, and you can see that there are dowel pins that allow me to transpose a water line up using a straight edge, and that then gets transferred onto the frame construction leg, which you can see sticking out there, and that will correspond to a common plane that runs all the way through the boat and allows me to get all the framing at the correct height once we set these frames up on the strongback system. Once a successful dry fit has been done of the frames, we can start to glue them up on the same construction table. So all of the mating faces first get wetted out with unthickened epoxy, and then once I've allowed that to slightly tack up, we can assemble the joints with some thickened epoxy and glue the frame together. The dowel system here just helps to retain really good alignment between parts and make sure that everything relocates where it should be. Once that's cured, we can remove the pins that I use to hold the gussets in place, and then just clean everything up to get a nice frame. Now, some of these frames have bulkheads on them. Some of those bulkheads are visible within the finished cockpit of the boat. So for those particular frames, I wanted to do a nice veneered face to the parts that you're going to see. I don't particularly like the grain that you get with plywood, and I wanted some nice book matched straight grained faces to my bulkheads. So I cut some veneers from some utility stock that I've got, and you can see that I'm book matching those veneers to get a really nice pattern on the bulkheads, and those all got laid out in place, cut to size and then taped together as a dry fit. And then I can do a glue up of the veneers. So again, both of the mating faces get rolled with unthickened epoxy, and then I apply some thickened epoxy with a notch spreader and then place the veneers in position on the bulkhead. You can see that I've got a red bag underneath the bulkhead there, and this is to form a vacuum bagging envelope. So you can see here that as the vacuum pressure reduces inside that envelope bag, we've got a pressure that's coming in from the atmosphere around and giving a good even clamping force to the whole of that face veneer. Once cured, they can get trimmed up and cleaned up, and then around the internal apertures of the openings, so these will form crawl spaces up in the forward end of the boat, I'm doing a laminated timber section which is just going to form a nice round combing to the opening of that aperture and make sure that there's no damage done to the veneers further down the line. So this gets laid up with several different pieces of thin timber to form the lamination. Then it gets cleaned up with routers and rounded over to give a nice soft edge. And you can see the look there that I've achieved with the bulkhead frames nice book match veneer on the faces, and then a laminated aperture on the opening. So one of the things that I'm doing with this boat build is experimenting with some new ways in which we can build wooden boats, and utilizing CNC to kind of push that forwards and modernize the process, hopefully streamline it somewhat. One of the key differences that I'm doing with this boat is to return the frames to the CNC machine once they've been glued up, and then I'm using the information from within the CAD model to carve those frames in a 3D fashion. So I'm pre-cutting all of the bevels on the frames, I'm cutting in all the notches for every timber that will run through, and this work early on in this stage should massively transform not only the speed with which I can set this boat up, but actually the way in which I can build it. And you'll see that a little bit further down the line in the series when I actually get to set these frames up, which is not far away now. So the way that this gets cut is in a two-sided operation where the whole frame is located on the machine, and then one side is cut with a roughing operation to remove the bulk of the material, and then a finishing operation just to get that fine beveled finish. So you can see the stepped roughing cut there. And then that is followed with a ball nose end mill that just gives a really fine finish to those bevels and notches around the outside of the frame. So this is done in two sides. The frame's cut on one side for the bevel, and then it's flipped and cut on the other side because some of the transitions through the frames require this two-sided operation due to the angles that they go through. And you can see the finished frame there and how that corresponds to the finish. Once the framing is all done, we need ourselves a stem. The stem within this boat is a laminated component. So the first thing I do is cut a CNC cut jig, which will help me to form that lamination. This will also help me to transpose some lines from the jig onto the stem, which I'll use later on. And I'll also use this jig for positioning the stem within the strong back assembly. So I machine a huge stack of laminations. We bend those into place, and you can see that those taper out for the areas of the lamination where we won't need so much material. Again, using West System epoxy to laminate this. So I'm using a combination of unthickened epoxy to wet out the laminates first of all, and then in between each of those laminate layers we do a high density filler mix put on with a notch spreader. And you can see that I've just got a little dowel in the right hand side of the stack there, just to help me to keep these laminates all together and positioned as I wrap them up and put them into the jig. So this all gets done on a polythene sheet, wrapped up for the entire lamination stack, which allows me a nice clean glue up as I clamp this shape. Once that's cured, it can then be cleaned up. So I'm running this through my sanding machine, which copes with taking off that excess epoxy really nicely and just helps me to bring that lamination down to size. And you can see we've got a really beautiful glue up there, really nice tight glue line. This component is also one that is getting shaped on the CNC machine before it goes into the boat. So I'm doing a two-sided 3D beveling operation on this to cut the rolling bevel into the shape of the stem, to account for a small amount of springback that we had when we laminated, and to also cut all the notches which will land all the topside battens and the chines into the stem. So this is a huge amount of time saved compared to how you would do this traditionally by using the timbers to cut these notches in further down the line. This will enable me to actually steer the position of those timbers with having that information in the stem already before I actually start the build. And you can see the way that that is carved again with a roughing and finishing operation on the CNC machine to place all of the various landings into the stem. All in all, a process that I've never actually seen done before by pre-shaping a stem this far ahead of its setup within the boat, and that is going to save me a huge amount of time when it comes to finishing things off. So once I'd finished the stem and the first 3 frames within the boat, I decided to do a trial run setup upstairs. So the first thing that I need to do is to attach legs to all of the frames. That gets done back on the frame construction table again. And then attach the jig back to the stem as well, which you can just see positioned back in place there, which is going to land it within the strong back assembly. I then needed to cut my strong back assembly, and that is also CNC cut. That slots together with this notched tenon system, which knocks through the main rails of the strong back for each of the rungs, and those get locked into place with a locking tenon joint. So this gives a really tight positive alignment between parts. It helps me to ensure that each of the rungs within the strong back position are perfectly equal from side to side. They're perfectly vertical, and in one of the frames instances they're angled correctly as well. So then I can get the frames and the stem into place on the strong back, and you can see that these get set up with a laser level that gets fired all the way through the boat as one common waterline plane. That is referenced on each of the frame legs, and it's also referenced on the jig that supports the stem, which you can just see going into place there. Those help me to get a perfectly flat plane through all of the boat and get frames square but also level in reference to each other. And you can see the results of the pre-beveling process there. Everything is landing really nicely, and there's going to be next to no shaping to do to this boat once we get it set up and we start putting timbers in. You can see a little trial fit of one of the chine rails there, and I was just doing a rough cut to quickly land that into the stem and see how things looked. All in all, I was really pleased with how this process went, because this is a little bit of an unknown as to how well this was going to translate from the CAD model into real life, certainly when it comes to the lofting of the timbers. But you can see that I'm just springing a little test plank into place here just to see how that lands, and it was absolutely perfect on each of the frames. So I'm really looking forward to getting the boat set up like that. So the transom comes next. It's a curved transom on this boat, which is formed from laminations, and that is built in this curved jig, which you can see me building here. So you've got these rail sections that are CNC cut to form the curvature, and they lock together using this half housing joint with the dividing sections that space all of those rails out. A skin then gets put onto that jig, and that is pre-engraved with the shapes for the lines of the transom framing and the outer planking. I can then start to cut the transom pieces. So these are CNC cut again, and I did these from thick stock initially, and then I cut them into their laminated thicknesses. So we've got 5 layers in total within each of the framing components of this transom. So they all got cut from 1-inch stock and then sanded down to size for the correct lamination thickness to make up the total framing thickness. So the parts can then be brought into this jig, and the lines that are engraved on it are used to position parts correctly, and they first of all get laminated as individual components and glued up so that I can form their curvature on an individual basis. So you can see here with most of these parts I've put some screws right through into the jig to pull them down nice and tightly, and then just to consolidate everything I clamped some timbers across the full span of the jig just to make sure that they were pulled into the correct curvature. Parts can then be cleaned up on the sander, and you'll notice here that there's a correct size and an oversized lamination. So the smaller size lamination tells me where to sand down to with the other parts. I then do a dry assembly of all the parts on this jig, and using all the marking lines on it to arrange the various different components in their correct places and make sure that we've got everything in its proper position. I'm using the Festool domino to create really strong tenon joints between each of the components on the transition between the frame bottoms and the frame sides, and the joint as well down at the keel where the 2 bottom frame sections meet. There you can see the finished curved outer transom framing. So the next thing to do is to start to install some of the internal components that go within the transom framing. So there's this little foot that lands down onto the keel section. There are a range of different posts that run vertically between the bottom framing and the deck beam, and these all need shaping and fettling to get them to land into the compound curves of the transom framing, but also correctly orient themselves so that they are nice and vertical and straight, because they're also landing onto other components that will sit within the boat, such as the stringers, which we'll look at in just a bit when we start to laminate those. So these all get set into the transom framing with these bevel notches that allow a nice smooth landing, and plenty of glue surface area as well. There's also some big cheeks that fit into the bottom corners of the transom, and these will take the 2 exhaust ports when they run through eventually, and they'll also give a huge amount of strength into the chine region of the transom framing. Up next are the 2 stringers. Now these are 2 big laminated beams that run from the transom right through to frame 2 within the boat. They're 2 huge pieces of timber, and these also get formed on a CNC cut lamination jig. This jig forms not only the mold that allows me to put the curvature into the laminations and to form the stringers, but it also gives me all the information for the notches and the bevels on these stringers that then gets transposed to the finished wood part and used to pre-shape them ahead of time. This could be done on the CNC machine if you had a CNC machine that was big enough, but this is way too big for my machine. So we're using CNC to give that information on the jig, and then we'll transpose that and shape that manually. So I'm using larch for this, Siberian larch, which is a softwood but a really hard softwood. So this is roughly equivalent to the utility that I'm using for most of the rest of the boat, but it's a little bit lighter, so we're going to save some weight within this big timber section. You can see a little scarfing jig that I've made here just to cut some scarves for all of the laminations, and the primary purpose for this really is just to tack those together so that each of the laminations is in one long piece. That's the reason that I'm using fairly short scarves here, and actually because these are sandwiched within a full lamination stack which bridges each of the scarf joints, the size of them isn't quite so critical as if this was a standalone timber. We'll then apply lightly thickened epoxy to each face of the laminate and then stack that up into place and pull in that curvature and allow that to cure. So you can see the finished lamination stack here, and because I'm doing this up on my mezzanine floor, I've actually got that jig screwed down to the floor just to make sure that there is no deflection in that as I pull those timbers into shape. Now these are slightly over width at the moment, so post glue up they get cleaned up with a hand planer, again because I couldn't fit this through any of the machines down in my shop. And then I begin to shape it. So the first thing that happens is this gets shifted away from the jig, and I transpose the initial curve back onto the stringer to just bring it down to its final size and take out any spring back that's happened within that lamination. So that mostly gets done by hand because it was only a small amount of material to remove, and I did use an electric planer for some little parts. Once that then fits back against the jig properly, I can transpose the primary bevel line and all the notches for each of the frames. That bevel line can then get shaped in with a hand plane and just brought down slowly to the pencil line there. And then I can cut in each of the notches, which is going to land the frames that will run through the stringers and be bonded in place further down the line. So you can see that all of that information is transposed from that CNC jig back onto the stringer, and that then allows me to cut these in place and pre-locate everything before this gets set up in the boat. So the only other timber to do off the boat is the shear clamp, and this is the one that runs along the transition here between the side of the boat and the deck. This is quite a complex timber and it twists and bends in various different directions, so it's quite a difficult one to form, and for that reason I came up with a CNC cut solution that is going to allow not only myself but other people building this boat to form this complex timber in a much more simple way. So this is made up of 3 lamination layers, and these are cut with the curvature in plan view already in place. So it takes a huge amount of stress out of the timber there, and you can see how those shape to form that curvature as it comes in towards the bow of the boat. The curvature as viewed from profile view is formed between these three laminations slipping over each other, and this also allows the twist within this particular timber as well. You can see just how big these timbers are because I've got to take them outside to turn them around. So the three individual laminations are formed and jointed with this scarf joint system that runs down the length of them. That helps to reduce grain run out as these timbers turn the corner, because there is of course quite a sharp turn. Those three laminations then get stacked on top of each other, and the differing profiles to their size actually forms the twist that happens down the full length of this timber. So you can see that as we come up forward, those three laminations are the same. As they approach the kind of turn and around about the frame 5-6 region of the boat, they start to stack out, which allows for the flare of the top sides. As we come back to around about frame 9 and 10, things get a little bit vertical again as the sides of the boat even out. And then as we come from there back further aft, you'll see that that then twists the opposite way as we start to account for the tumble home when we are approaching the transom. So you can see how that helps us to form the shape of this timber. So there's a look through some of the work that I've done to date. The boat is now downstairs, all the parts are now downstairs anyway, and the next step is going to be to get the strongback set up and to start actually forming this into a boat, putting all these components together. This is now taking over the primary spot within my workshop, which means it's the main thing I'm working on, and hopefully we're going to start to push the project forward, which would be a really nice stage to get to. Now, this project is something that I'm trying to kind of self-propel finances wise, so I massively appreciate you guys watching the videos. I really do rely on getting good videos in order for this to actually work, and if you guys want to put a little bit extra into that and to help to fund the project, then please check out my Patreon page where you can get early access to videos, you can get discounts to boat plans and online courses, all the things that I sell on the website as well. So there's some extra little benefits there for you. Massively appreciate any additional support that you guys can offer to help me propel this thing through to completion. So that's where we're up to. Stay tuned for the next video when we're going to start to build a strong back here and stand all this up, get it properly boat shaped. Hope you enjoyed it, and I'll catch you in the next one. Cheers guys.